So continuing with this, we're going to move on to example number 4. We're going to write each trig equation as an algebraic expression of x. Okay, so look at what you have here. You have cosine of something plus something else. So this is already, you know, a sum and difference identity. All right, what you want to do first is go inside the parentheses, all right, and see if you can simplify any of the terms, right? So here we have arc sine of root 3 over 2. What's arc sine of root 3 over 2? Pi over 3. So the angle which gives you root 3 over 2 for the sine. This is from lesson 6, right, of the last chapter. So this is pi over 3. So now what I have is, this is cosine of pi over 3 plus arc cosine x. All right, now I still have cosine of a plus b, but now it's a little bit simpler. So I'm going to do cosine, cosine, sine, sine. So this is equal to cosine of the second minus sine pi over 3 sine arc cosine x. Okay, it's like this. All right. Okay, now what's cosine pi over 3? It's 1/2. All right. But here, what about here? Cosine and arc cosine go away, so you just have x minus sine pi over 3 is root 3 over 2 times, now I have this business, sine arc cosine of x. For this one, we have to do a little bit of work. Okay? Here you have a triangle, the cosine of which is x. This is like what we did in the last lesson of section 6 as well. All right, so you have a triangle, the cosine you have an angle in here, the cosine of it is x. Okay, so adjacent over hypotenuse is x over 1. And what would that missing side be? So do you guys remember the a squared plus b squared equals c squared? So this is root 1 minus x squared. And so now the sine of that angle is opposite over hypotenuse root 1 minus x squared. So for this, you have to go back and look at the stuff we did in 4.6. Okay, so in 4.6, this blue part was a single problem on its own. Now it's just 1/4 of a bigger problem. All right. So we're building up. So next, here I have x over 2 minus root 3 times root 1 minus x squared over 2. And I can actually combine all of that together. This is all in the same fraction with a denominator of 2. I have x minus, here a root times a root combines, so I have 3 minus 3x squared in the root, and that is the final answer. For this next one, we're going to do the same thing. Go inside the parenthesis first and see if there's anything we can simplify. The arc cosine 1 over 2, you want the angle for which cosine is equal to 1/2. That's the pi over 3 as well. So that's pi over 3. So what I have now is sine arc tangent minus pi over 3. If you want to minimize the symbols you're writing, what's another way to write arctangent? It's like inverse tangent of x. Feel free to do that. Either way is fine. I'm going to do it this way just to show you that you can. Inverse tangent minus pi over 3. So this is going to be sine of the first, cosine of the second, minus cosine of the first, cosine of the second. All right, and let's just make sure I have sine, cosine, cosine, sine. Whoops. I didn't have it right. It's sine of pi over 3. Sine, cosine, cosine, sine. And since it's a sine, the minus stays a minus. Okay? All right. Here, this time, the one we have to do a triangle for is here, right? There is a triangle right there. So there is a triangle with an angle, the tangent of which is x. So opposite over adjacent is x over 1. Now, I'm missing the hypotenuse this time. The missing sides are all the square root of, okay, something minus something or something plus something. If you're missing the hypotenuse is the biggest side, right? In order to make it the biggest side, you're not going to subtract quantities. You're going to add quantities to make them bigger. Think of it that way. So it's 1 plus x squared. Okay? Now, the sine of that angle is going to be x over the square root 1 plus x squared times cosine pi over 3 is 1/2 minus, now look, this one is a triangle inverse tangent of x. That's the same triangle. So I just use the same triangle, okay? Same triangle. And I now want the cosine, so it's 1 over root 1 plus x squared times sine of pi over 3 is root 3 over 2, right? If the cosine was 1/2, the sine of the same angle is root 3 over 2. Okay, so what do we have now? Do we have the same denominator again for both of them? We do. And that denominator is 2 root 1 minus x squared, plus x squared, sorry. Okay, numerators. First I have x times 1, x minus root 3, and there you have it. Okay? All right, questions? Okay, this next one here, yes.
How exactly do you know it's the same triangle again?
Because here, where did we start? We said there was a triangle, the tangent of which was x. And here too, there is a triangle, the tangent of which is x. So that's the same triangle.
Oh, it's not like tangent of x.
No. There's a triangle with an angle, the tangent of which is x. Yeah. Okay. This next one, look at this. Cosine of inverse theta equals cosine theta. You know what that is? That is an identity from section 1. Here. Cosine of inverse theta is equal to cosine of theta. That's that identity. So what that problem is asking us is to sort of prove that that identity is true. Okay? We're not really proving, we're verifying, which is like proving. So to verify, okay, to verify means you have to use trig identities to prove left side equals right side. Okay? All right. So what is it that we have to prove? We have to show cosine of negative theta is equal to cosine theta. All right? What we do is normally you start working on one side only, okay? And then you do things on the one side, and then magically it ends up equaling to the other side. So the side here that there is more to do with is the left side, right? Cosine theta is just cosine theta. So the left-hand side. Okay, how can I rewrite cosine of negative theta? Well, how can I get, what's another way to write negative 3? Is 0 minus 3 the same as writing negative 3? It is. So that's how I'm going to write that. I'm going to write this as cosine 0 minus 3. Theta. 0 minus theta. And then what we do is, and this is like where like it requires great skill, we like to align those equal signs, okay, top to bottom. So you kind of have to like adjust so it works that way. All right, it's kind of like it's like a ninja skill. All right, so look at what we have now. We have cosine something minus something. That's a sum and difference identity. So that's cosine plus sine equals. You see how it just goes like right to that equal sign? I mean, it's like, right? Precision. All right. So now we're going to simplify. Let's see, is this eventually going to equal cosine theta? It's not looking very likely right now. But what's cosine of 0? Cosine of 0. Not inverse cosine of 0. What's just cosine of 0 is 1. When the angle is 0, cosine is 1. So that's 1 times cosine theta. What's sine of 0? Nope. Sine of 0. 0. Not inverse sine. Just sine at 0. When the angle is 0, what's the sine? It's 0. So what I have here is 1 times cosine theta plus 0 times sine theta. Well, what's 0 times anything? 0. So what do I have left? 1 times cosine theta. And does that equal cosine theta? It sure does. So you see how we verified it? Right? So with these, you're not looking for an answer. You have the answer. You just want to manipulate one side of the equation to look like the other side of the equation. All right? Okay. Let's do one more. Another identity. This is another identity. Okay? We want to verify cosine theta minus pi over 2 is equal to sine of theta. So, okay. Same thing. All right, so we're going to do cosine plus sine is equal to, hey.
Yeah, good morning.
Is equal to, we don't know. All right, so let's see. What's cosine pi over 2? 0. So that whole thing becomes 0. What's sine of pi over 2? 1. So here I get 0 plus sine theta times 1 is equal to, and look, that's just sine theta equal to sine theta. Okay? So you verified it. Okay? All right, questions? Okay, now let's solve an equation. Okay? Look at this equation. Cosine x plus pi minus sine x minus pi equals to 0. Well, okay. This is 2 of these problems combined into one. Because look, this one is a cosine a plus b. This one is a sine a minus b. So now we have to do each one separately as its own identity. So let's do the red one first. We're going to start all the way over here. So we're going to do cosine x, cosine pi, minus sine x, sine pi. Okay, there's a minus there, which means for the next thing we need a parenthesis. Okay, I'm going to use brackets. Sine x cosine pi minus cosine x sine pi equal to 0. Okay, so look, we have cosine, cosine, sine, 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 cosine, cosine, sine. Okay, we're good. All right. So now, let's see what happens here. Anything we can simplify, you need to simplify at this step. What's cosine of pi? -1. It's on the other side, -1. Sine of pi is 0. Okay? Cosine of pi, -1. Sine of pi is 0. Oh, I love those zeros. Okay? Because look at what happens now. Here I have cosine times -1, which is just negative cosine x. Okay? That's negative cosine x. Minus 0. Here, minus negative sine x, so that's here, plus sine x, minus or plus 0 equal to 0. Okay? Cool?
Yeah.
You're sure? Okay.
Why is the sign plus? Why is it plus sine x?
Because there is a minus here and a minus there.
Oh, yeah.
Yeah? So now what I have is negative cosine x plus sine x is equal to 0. Okay? And this is one that we haven't really seen before. All right? So you're like, what? Do I square it? I mean, you can, but there is another way to do it. What if we move one of them to the other side? So what if I say sine x is equal to cosine x? Now let's think about that. We're looking for the x's, which is the angle. For which, and just think about this for a minute. Let's not answer just yet. We're looking for the angle for which sine and cosine are equal. So think about that for a minute, just to yourself. Can you think of an angle for which sine and cosine are equal? Okay, what do you think here? Pi over 4, right? That's like that meme, like comes in like 30 minutes late, answers first question. So, pi over 4, what else? Where else? Okay, so pi over 4, yes, for sure.
In the other spots, it would be like they're negative or positive. So.
Okay, so here at 3 pi over 4, here at 3 pi over 4, sine is positive, cosine is negative, so that doesn't work. 5 pi over 4, sine is negative and cosine is negative, so that works too. Here, 7 pi over 4, sine is negative, cosine is positive, so that doesn't work. So it's just 5 pi over 4 and 1 pi over 4. Woohoo! All right. Okay, moving right along. Next one. Okay, this one is like straight out of calculus. Okay? This one. So we're going to get used to this notation from now. And then, it's going to make appearances every now and then. And we're going to build up until we get to chapter 12. Okay. We want to expand the formula for the difference quotient. We're going to write this as g of x. Okay? For f of x is equal to cosine x. Right. So here's what this is saying. This is given. Okay? We're going to use that to build this. Use f of x to build this. Okay? All right. Who are the key players in what we're building? I have an f of x. What's f of x? Cosine x. Now, go with me here. If that's f of x, what's f of 0? Think back to algebra 2. What's f of 0? Cosine 0. What's f of a? Cosine a. What's f of podium? Cosine podium, right? So what's f of x plus h then? Cosine of x plus h. You see how that works? And look, that's another term in that stuff that we're building. Okay? So let's write g of x then. G of x is equal to, let's see what we had here, f of x plus h minus f of x all over h. So this is f of x plus h, we just made that cosine x plus h, minus f of x, we said is cosine x over h. Okay? But we can expand this, can't we? Because we have cosine of a plus b, right? So let's expand that. So that's going to be, in the red, cosine x, cosine h, minus sine x, sine h. Cosine, cosine, sine, sine. And then the rest is minus cosine x over h. And again, I know you guys are all the types of students who really want to like simplify and combine things, but we have to get used to the fact that this will just not simplify any further. So that's it. That's your answer. This is it. We're done. This is g of x. Okay? In chapter 12, we'll do more things with this. Okay? All right, and that's section 4.